All right, so now that we've established how we can evaluate sine, cosine, and tangent, if we know the coordinates, the xy coordinates of the points around the unit circle where the terminal side of the angle crosses the circle, let's talk about how we can evaluate sine, cosine, and tangent for very specific angles on the unit circle that have familiar reference angles. So I'm going to start with angles on the unit circle that have a reference angle of 30 degrees, just 30 degrees. So let's take a look at the diagram here. All right, what I've done is I've drawn our unit circle, and you might remember that the unit circle has a radius of 1, all right? That means the distance from the origin to this point, origin to this point, origin to this point, and origin to this point, they're all 1. So all 4 radii drawn in here are 1 unit long. That's a unit circle. But I've specifically drawn 4 angles, bow tie angles, that all have the same reference angle of 30 degrees, okay? So we've got 4 angles, there's 1 in each quadrant. In quadrant 1, we have a 30-degree angle. Here is the initial side sitting on the positive side of the x-axis. The terminal side of the angle is here. That's 30 degrees of rotation in a positive direction. Remember, we're rotating counterclockwise. Initial side, terminal side, 30 degrees. There's our first angle, all right, in quadrant 1. And I'm going to talk about how we can figure out the coordinates of the point right here where the terminal side of that angle actually crosses the circle, all right? We'll come back to those coordinates in a second. Let's just talk about the 4 related angles in each quadrant. Once I move into quadrant 2, all right, a reference angle of 30. If you want to figure out, well, how big is the actual angle itself with the initial side on the positive x-axis rotating all the way here to this terminal side, that would be 150 degrees of rotation. Starting at 0 degrees, rotating all the way to here, this terminal side. It's essentially 180 degrees minus 30. That's 150 degrees, that's the angle in quadrant 2. And that angle has coordinates associated with it where the terminal side of the angle crosses the unit circle. We'll come back to how we come up with those coordinates. Let's move into quadrant 3, our next related angle, our next bow tie angle. Starting at the initial side, rotating in a positive direction to here, that's going to be 180 degrees plus 30. That's a 210 degree angle, a reflex angle in quadrant 3. And finally, in quadrant 4, starting at the initial side, rotating in a positive direction all the way around to this terminal side, that's 330 degrees of rotation. Another way to think about that, it's a full circle of rotation minus 30 degrees, minus the reference angle, 330 degrees. So what we have are 4 related angles, 4 bow tie angles, 30 degrees, 150 degrees, 210 degrees, and 330 degrees. They all have the same reference angle of 30 degrees. And notice where the 30-degree angle is located, the reference angle. 30 degrees shows up between the x-axis and the terminal side. 30 degrees shows up between the x-axis and the terminal side. Again, 30 degrees, your reference angle, shows up between the x-axis and the terminal side. And one more time, 30 degrees shows up between the x-axis and the terminal side of the angle. So if you're ever confused, where does the reference angle go? The reference angle always sits between the x-axis, and the terminal side of the angle. The x-axis. I used to do this all the time last year, all right? So your reference angle sits between the x-axis and the terminal side of the angle. Okay, so now that we've talked about our 4 related angles, our 4 bow tie angles, I'm just going to throw up here a couple other things we know. Now what you might notice is that what I've done is I've drawn an altitude. I've drawn an altitude from the point on the terminal side of the angle where the terminal side crosses the unit circle, and I've drawn that altitude to the x-axis. Over here, from the point, I've drawn an altitude to the x-axis. From here, I've drawn a point to the x-axis, an altitude to the x-axis. And from this point, an altitude to the x-axis. Again, to the x-axis. And when we do that, those right triangles pop up. So you got 4 right triangles for the 4 bow tie angles, the 4 related angles. And as it turns out, these are all 30, 60, 90 triangles. So let's pull one of them off, right? Let's pull this triangle off and pop it over here. 30 degrees, 60 degrees, 90 degrees. Okay, 30, 60, 90. Let's think back to when we initially covered special right triangles. We said that we actually know the relationships between the sides. So given a 30, 60, 90, the side across from the 30, if that's W, then the side across from 90, the hypotenuse, is 2 times W. And if the side across from 30 is W, then the side across from 60 is W root 3. All right, so now let's think back to this triangle here. We established that this is the unit circle. And so we actually know that the radius, this distance here from the origin to this point, is 1. So that means we actually know this. We know that this length here, from the origin to this point, from the origin to this point, that is 1 unit, that's the radius. So that means 2W is equal to 1. This length is 1. Well, if 2W is equal to 1, if the hypotenuse of this triangle is 1, that means that W is 1/2. That's this distance here. And likewise, that means this distance here is 1/2 root 3. 1/2 times root 3. And I'm going to write that as root 3 over 2. So I actually know the lengths of the 3 sides of this triangle because I know the radius of the unit circle is 1, and therefore I know the hypotenuse of that triangle is 1. Okay, so now let's think about how do those distances help us find these coordinates. Okay, if you start at the origin and you want to get to that point, you have to go over a certain amount and up a certain amount. Therefore, I would have to go over whatever this length is. That's root 3 over 2. I go over root 3 over 2, and I go up this distance. That's 1/2. Over root 3 over 2, up 1/2. There are the coordinates of that point. And they're both positive because I'm moving in a positive direction on both axes. Okay? So these values, those just come from what you know about 30, 60, 90. And the fact that our reference angle here is 30 degrees. Well, let's take that into quadrant 2. What you might notice is that the coordinates of this point and the coordinates of this point, they have the same numeric values. It's just that all of a sudden the x-coordinate becomes negative. Well, why does that happen? Well, think about this. This is still a 30, 60, 90 triangle right here, except now it's in quadrant 2. The lengths of the sides of this triangle are the same as the lengths of the sides of that triangle. So this distance from here to here is still root 3 over 2. And this distance from here to here is still 1/2, but we're on a coordinate plane, and so we have to be thinking about direction. Therefore, to start at the origin and go to this point, I'm going to move backwards on the x-axis. That means I'm moving negative root 3 over 2, positive 1/2. So the x-coordinate is negative, but the y-coordinate is positive. Let's move into quadrant 3. Another 30, 60, 90 triangle with the same exact side lengths, but we have to be thinking about direction. Look at the coordinates. Now both x and y are negative. Back root 3 over 2, down 1/2. Negative, negative. And then finally, in quadrant 4, I'm moving in a positive direction, root 3 over 2, and a negative direction, 1/2. So your y-coordinate becomes negative here. So now that we've established how we can set up the coordinates all the way around the unit circle for 4 bow tie angles that have the same reference angle of 30, we can actually use that information to evaluate sine, cosine, and tangent for all 4 of those angles. And we're going to actually see there's a pattern here. There's some repetition to what comes up, okay? So if we think about the sine of 30 degrees, remember what we talked about in the last video? The sine of any angle on the unit circle, any angle theta, is the y-coordinate over the radius. Well, the radius of this is 1. Therefore, all I have to do to find the sine of any angle on this circle is to take the y-coordinate and divide it by 1. Okay, so sine of 30, looking at your y-coordinate, that's going to be 1/2 divided by 1. Therefore, the sine of 30 is 1/2. It's positive. Okay, let's talk about the cosine of 30. Cosine of any angle on the unit circle is the x-coordinate divided by the radius. Well, the radius of this circle is 1. It's a unit circle. Therefore, the cosine of 30 degrees is root 3 over 2 divided by 1, which is just root 3 over 2. Keep it going. Tangent of 30. Tangent of any angle is the y-coordinate over the x-coordinate. Now, this is where we might have to do a little bit of calculation, because now I'm not just dividing by 1 anymore. I'm not incorporating the radius in tangent. So tangent is y-coordinate of 1/2 divided by x-coordinate of root 3 over 2. And what I've done down here is remind you how you can rationalize. So when we've got 1/2 divided by root 3 over 2, y coordinate divided by x coordinate, remember dividing by a fraction is the same thing as multiplying its reciprocal, by its reciprocal. So keep, change, flip. 1/2 times 2 over root 3. These 2's are going to cancel. I've got 1 over root 3. We got to rationalize that denominator. That means I take the fraction 1 over root 3 and multiply by root 3 over root 3. And then that finally gives me root 3 over 3. Therefore, tangent of 30 degrees is root 3 over 3, and that's the math behind it. All right, so I've got sine, cosine, and tangent for 30 degrees, the angle in quadrant 1. As I expand into 150 degrees, I'm moving into quadrant 2. We're going to see these same values pop up again for sine, cosine, and tangent. The only difference now is that we might see some of them become negative, all right? So let's think about it. Sine of 150 degrees. 150 degrees is in quadrant 2. Its reference angle is 30. Here are your x and y coordinates, okay? So the sine of 150 degrees is the y coordinate, 1/2, divided by the radius. The sine of 150 is positive. That was the same as the sine of 30. But now look at cosine. Cosine of any angle on the unit circle. X coordinate divided by radius. X coordinate is negative. Divide by radius of 1. Cosine of 150 is negative root 3 over 2. So the cosine of this angle in the second quadrant is negative in its value. And then finally our tangent. Tangent is y coordinate divided by x coordinate. 1/2 divided by negative root 3 over 2. I know what the math of that division looks like. I just have to make sure I get a negative sign on the value. Negative root 3 over 3. It's a positive divided by a negative. So again, the values are exactly the same, but notice that in quadrant 2, cosine and tangent are actually negative. Sine remains positive. Let's move into quadrant 3, 210 degrees, all right? Same exact reference angle of 30, so I'm going to see the same values repeating. I just have to be aware of where the negative signs go. So sine of 210, look at your coordinates here. Y coordinate over radius, negative 1/2 over 1. That's just negative 1/2. Cosine of 210, negative root 3 over 2 divided by the radius. That's negative root 3 over 2. And finally, tangent of 210, you're going to be dividing a negative by a negative. It's going to become positive. And therefore, if I divide, let's make this negative 1/2 divided by negative root 3 over 2, that will be positive root 3 over 3. So notice in quadrant 3, sine is negative, cosine is negative, but tangent actually becomes positive because these two negatives here are going to kind of divide each other away. And finally, in the fourth quadrant, similar pattern with the numbers, just be aware of where your negatives go. So the sine of 330, y coordinate divided by radius, negative 1/2. Cosine of 330, x coordinate divided by radius, root 3 over 2. And the tangent of 330, y divided by x, a negative divided by a positive, that's going to be negative root 3 over 3. So notice, we did all of this without a calculator. That's why it's so important and why we really, really stress that you know the relationships for the sides in special right triangles, because it's all coming back here. It's all popping up so that we can evaluate all of these trig functions for specific angles without even using a calculator. We are coming up with exact trig values, not approximations. So that was your video for a reference angle of 30 degrees.